and that's why none of the speakers in the back of the room were working previously. So, but I think they were working. I think there was 3 sets this time, so they were working all the way in the back. Yeah. So, and for the Ann Arbor folks who are listening to the recording, I'll get the recording out to them today. Or if you want to be able to re-listen to it or something like that, I'll put all the recordings up. Apparently they've been recording them all, just never gave them to me. But last night was the first time that we needed it because the live stream wasn't working. But in any case, so I think the last night and the 2 weeks from now one should be pretty interesting. I would say our top students tend to graduate and go work at Acuity. That's been pretty much a truth for the last, call it 5 or 6 years. So, the folks that you see get announced as like, outstanding senior and that kind of stuff, they pretty much are all going to Acuity. Acuity also has an internship program, and I think for the last 6 years, we've had 4 interns that have gone there, and all 4 of them turned into full-time jobs at Acuity. I'm pretty impressed with the company in general. One thing I think is really cool about it, he talked about it last night, that I think is an important thing to keep in mind with your computer science education, and also the time you decide to dedicate outside of class, is what they're expecting in a place like that is for you to come in with the ability to learn and the ability to problem solve. They're not so much concerned over the exact languages you had in class or whether you did this, that, and the next thing, but they want you to be able to work in teams. They want you to be able to work on projects. So doing things outside of class that get you involved in those things, like some of the folks in here have been doing, I think are very good things. Stuff like hackathons are similar one-day things, but if you can get involved in a group that just works on some project for 3 or 4 hours a week for the length of a semester or something like that, maybe 5 hours a week might make more sense, just so you feel like you actually make progress. I think that could be pretty beneficial for going into a place like that and being prepared. One thing I've always been impressed with Acuity is that they kind of have a training program. So when they hire you, it's almost like your first day of college. So you show up there, they have like a January class and they have a June class. They don't really hire in between unless it's out of desperation. So the June class would be like the bigger class. So that would be hiring people that are graduating in May. And they get them there onto the Acuity campus up in Sheboygan. And there might be, I think this last year's June class maybe had 20 people in it, something like that. These were computer programmers that were hired, and they took them through a 3-month training. I mean, they were in a classroom. They were given all the different tools, the computers and things like that they would be using on their actual desks there, and they were taken through coursework, effectively training them on taking their foundation that they got from college and training them on the Acuity way. Here's the tools you'll be working with at Acuity, all their different security protocols, because they're dealing with a lot of sensitive information. So they're teaching you on the proper way of handling that kind of information, but they're teaching you COBOL, very old programming language, because a lot of their stuff is still left over from this old language. My wife's a COBOL programmer. So it's somewhat of a legacy language, but also something that's not necessarily going away anytime soon. Because when you get placed on a team at Acuity initially, you might get put on one of the COBOL teams, or you might get put on one of the Java teams, but any way you cut it, you're probably going to have to talk to folks from the other teams. And then once you're on a team, you have some, after maybe the first 6 months or something like that, you have some flexibility to say, hey, I hate this, I want to move to a different team. And I think they kind of allow that type of stuff as well. But I'm pretty impressed with their approach to getting people going. I compare that to some of our other students that graduated even this last semester who went to like a direct competitor to this. So we had a student go and work at West Bend Mutual, which for all I know is we don't have a direct relationship with them, but for all I know is a solid company. But her experience was substantially different. Didn't have any training, basically showed up the first day of work, They said, here's your machine, set up your development environment by the end of the week. She didn't know what tools she was supposed to, nothing, just set up your development environment. And part of that is because the person that was managing her was busy too and had, I guess, a high priority project they were working on, so they really didn't have time to bring her up to speed. But just a very different approach to, let's throw you in the deep end with sharks, versus we don't expect you to be productive for 6 months. Those are two very different approaches, obviously. And I've always been impressed with Acuity, how they invest in their employees, but that investment also comes with pretty good employee retention. They don't have a whole lot of turnover. Typically, you saw yesterday the guy mentioned, he started with the company when it wasn't even called Acuity, and worked his way up, and now he's second in command, and the guy who's currently CEO had his job prior to that. So, and all their general managers are people that came up from the bottom, so they tend to grow internally. So if you go and work at Acuity and you come in as a application developer, 15 years you might be running the show. If that's a direction you want to go. Otherwise, he talked about some of their different positions, like software architects and things like that, which tend to be maybe their top tier, still technical person. You're still developer, you're still doing your computer science-y stuff, but you're in charge of a bunch of people, but kind of the whole system. You know how all the different pipes connect to each other and stuff like that. Once you go above that, now you're doing more administrative stuff, maybe less hands-on day-to-day things. That might be something some of you gravitate towards. That might be something you don't. But whether you end up going to a place like an Acuity or not, I think it's very valuable. I think they mentioned they're doing the bacon tour up here, so they come to campus and they grill bacon outside, and you just go and eat bacon, I guess. But you hand them their resume, and they guarantee you a phone interview. Every single one of you should go and do that, whether you think you want to work at Acuity or not. You never know, you might get the internship or something like that to get you some experience. But bottom line is Acuity is an example of a company I think does their hiring and onboarding and things like that right. So worst case, you have a phone interview with somebody that you end up either not getting the job or not taking the job or whatever it is, but you gain some experience as to what that phone interview might look like, maybe from a company that kind of gives you some indications of a company that maybe does things in a pretty reasonable way. So you might be able to spot that in future type things. It is pretty competitive. Acuity is, kind of like, I don't know, the Harvard or the MIT around here. They get a lot of applicants and take a very small percentage of them. I don't remember what their applicant pool was last year, but I think they had something like 700 or 800 developer applications for it, and I think they hired 20. And we had one person out of our program in the June class, and that was Maddie, who introduced the guy last year. 2 years ago, we had 4 in the class. Before that, I think we had 3, and we've had at least a couple most years. So, we're putting out pretty decent programmers, I think, and they tend to be consistently hired at Acuity. And I have a pretty close relationship with with Marcus, who was there last night, and so I think it's a good setup, but that would be something you definitely want to get the phone interview for. And even if you suck at it or don't get the job, you at least learn something from the interview, and it cost you, what, a half hour of your life? You didn't even have to put pants on. Probably don't do a video chat. But you get what I'm saying? So definitely take advantage of that. And Jordan, the guy who's the human resources guy who was there, he's a perfect example of how human resources should be done as well. He's very personable. A guy who got hired there 2 years ago, Josh Curcio, he goes golfing with Jordan like twice a week, stuff like that. So, it's a very kind of tight-knit company. Go ahead.
Do you have any recommendations for our resumes? Like, should we say we started Python and Java, or
well, I would definitely list the languages you've been exposed to. So generally for resumes, be as aggressive as possible without lying, something like that. A lot of times what you want to do, especially if you're applying for a very specific job, go and look at what technologies that place works with, and then go and research those. Because one thing I'm telling you, and this is a truth, is once you get to, let's call it your junior year, you've been exposed to almost all of the baseline technologies. Just because there's some crazy sounding thing that came out a week ago that you don't know about, when you go and look at it, you'll say, oh, that's kind of like X. That's kind of like something I already know about. So you can spend a half hour reading about it, see what's different, what's new, what's whatever, and now you can say, I'm familiar with that technology. I haven't shipped any products. I haven't necessarily worked directly with it, but I've worked with technology X, which is a lot like that, and whatever. So a lot of times if you do that research ahead and you kind of know if this place is like we had the internship opportunity from a month ago or something like that with Optimal Blue, and you got the internship, right? Did they hire anybody else, or were you it?
I think they said they might hire one more person.
Okay. Well, he was the grand prize winner at this point, but they're a .NET shop. So, he was asking me some questions yesterday specifically about .NET stuff, and I think once you get into it, you'll start recognizing, oh, well, C# is basically Java. Every now and then you'll capitalize something you used to not capitalize, or you'll lowercase something you used to not lowercase, but it's very, very similar. So, and instead of Eclipse, you're going to be working in Visual Studio. And one of the nice things with Visual Studio that you'll run into is they're probably talking to either an Azure cloud or a local Microsoft SQL server for their database. And Visual Studio has nice little wizards for just saying, I want this guy to talk to that guy. And once you hook it up, then it's seamless as if it's local. So you're learning about the tool Visual Studio, and you're learning about the concept of a database, but you don't really have to handle the connection in between because the tool does it for you. We're going to be talking about something kind of similar to that today, and I'm going to show you the official way of doing it, and then we'll kind of screw around with the Eclipse way of doing it. But I want to show you the official way just as a starting point. That way, everybody can make sure that they have their project working the way it needs to work. Okay, so your resume question: be as aggressive as possible. I'm always happy to look at resumes and let you know what I think, but definitely make it targeted for a company. I definitely don't encourage you to lie on it, but be aggressive. Research it a little bit, prepare for the phone interview, whatever, and make sure you understand the right buzzwords when they ask you a question that involves something you at least have a cursory understanding of it. And also another thing, and this is kind of the advantage of phone interview practice, even if it's with a place, the more phone interviews you can do, or even in-person interviews you can do, the better, even if you're only mildly interested in the job. Worst that happens, you go in, you suck, you don't get the job, but you learn a little something from each one. You also learn the little patterns that different interviews do. We had a student I was just talking to yesterday, and this was kind of a somewhat of a weird situation, I guess possibly a God thing, but she interviewed for a position, I don't know, three months ago, something like that. And it was with Optimal Blue, actually. And it was a developer position that probably wouldn't be one of her strengths. And apparently the interview could not have gone worse. Basically, they asked her to write some stuff. She couldn't write anything. Just might as well have been Mr. Gonzalez in the interview. And then on top of that, the people who were interviewing her were kind of tech geeks and stuff like that. They were asking her about, what tech podcasts she listens to and things like that. And that's all fine and good. So you're going to have, one of the things Marcus talked about last night was culture at companies. Different companies will have a different culture, and that also kind of has to play into, your wheelhouse. if you're one of these super geeks, so, for instance, this place, it sounds like maybe that particular group that interviewed her at least are probably big into anime, listen to tech podcasts. They're that geeky, nerdy guy, club type thing. And that's okay. That's going to be very compatible with some folks. And for other folks, it'll be like, I'm not like those people. that's not my guys. That's not my clan. So it might be a turnoff. That might not be a something that's going to be compatible with you. Or maybe you become the balancing factor in that type of thing. But it does tell you something about the company. But in any case, apparently the interview could not have gone worse. Everything she was saying, it really could not have gone worse. She thought, she obviously didn't get the job, right? So 5 minutes later, they didn't even give her the interview, the tour of the place. So 5 minutes later, they told her, okay, we hired somebody else, or we're going to go in a different direction. Whatever their spiel is for, you weren't good enough. But something like 2 or 3 months later, she gets a call from one of their recruiters for a completely different kind of position, a business analyst position that sits as kind of the glue between the client and the developer. So you're the person who can speak human and you can also speak developer. And she interviewed for that. Apparently that went well, and she's negotiating a final salary now. She has an offer, but it's interesting how sometimes doing something that went so poorly then turns into basically her career. It was a good offer, I don't know, $60,000 or something like that for a full-time gig. You can find hired other places. I think this last year, right out of school, Acuity pays everybody the same. And so every single person that came in the June class this last year has the identical salary. So you don't have this situation where it's like, well, how much did you make? How much did you negotiate your salary? And I think that's a good thing. But I think that the people came in at around 67 right out of school, up at Acuity. And then after 2 years, you typically move to the next level unless you just really were not doing well. But I think it's really a 2 years in type thing. You move up to the next level. And I think the people who had come in at 64 from 3 years ago moved up to something like 71 or 72, 73, something like that. So low 70s as their initial raise 2 years in. All right, so other questions about the talk last night or resumes or anything else? Take your time in college seriously. Do stuff outside of class. Work on projects. Do things like with CU Launch. All these things add up to you setting yourself apart when you go and interview and getting a good job and all this other jazz. You're not going to learn that much in the classroom. You're going to learn a little bit about a little bit, and you're going to mostly learn about how to learn. Just is what it is. All right. You had another reading assignment, right? No programming assignment? Okay, so one thing I want to go over today for a little bit. Now, truth in advertising. What I'm about to show you is an industry standard. We're going to be looking at something called Git and GitHub. So this is an industry standard. Every one of you should know how to use this. For those of you who've worked on some external projects and things like that, you've probably had to download Git repositories and things like that, and maybe didn't know what the heck you were doing. But this is just the way to do it. So I'm going to show you kind of the cookie cutter way that will work with any sort of project. Then we'll mess with the integrated piece in Eclipse a little bit, which I've only messed with just for a couple of minutes here. It wasn't horrible, but let's do that as a second tier. I'm going to show you generic use of Git and GitHub. All right. So for starters, let's talk about what that is. How many of you have heard of GitHub before? Okay. What is GitHub? What can you tell me? What would you say GitHub is? Go ahead.
It's a piece of online software which allows people to collaborate on code.
Okay. I think that's a pretty good starting point. So GitHub is an online Git repository. And we can say public and private. Now, typically, the way GitHub has historically worked is you would, and they're now owned by Microsoft. Microsoft acquired them about a year ago. The way this has historically worked is GitHub has always been free for public repositories. So almost all open source projects you can find out there on GitHub. And you can just look at the code, you can download the code. It's open source. You can do whatever you want to it. But only if you've been invited as a collaborator are you able to actually put stuff towards that project. And I'll talk about that a little bit here in pictures, and then we'll actually do some of it. But GitHub is an online Git repository. So really the underlying tech is this thing called Git. So Git is the software type. So think of Git as kind of like Microsoft Word. And GitHub is a place for storing Word documents. All right, so GitHub has competitors, another one called Bitbucket. There's a couple of other ones that are compatible with Git repositories. Now, what is a Git repository? So this guy creates and manages repositories of, I'm going to say files, but really it's typically code. Git is typically used by programmers, but that doesn't mean it has to be. You could store all your homework in a Git repository if you wanted to. Now, what's the advantage of a Git repository? Stores all of your changes. Okay, so if you had a document, whether it's a code file or a Word document, whatever, let's say code file, so mostly it would be a text-based file. So you have a .java file, and you initially have it in your Git repository somehow. We'll talk about how that happens, but it's in your Git repository. When you make a change to it, it remembers, it shows you the current version of the file, but it also remembers past versions of the file. So if you have an inoperable software now, you can roll back to previous times when it did work. Go ahead.
So it's kind of like Google Docs except for code?
Yeah, I think so. With the exception that I don't think Google Docs gives you a convenient way of looking at the differences between files, where GitHub does. GitHub lets you say, you know, show me the previous version of the file, show me the current version of the file, what did I break? Here's the differences between those two. Does Google Docs allow you to do that?
Kind of. If someone else has edited the document, I believe it gives you the option to see the changes.
Okay, yeah, fair enough. So then the answer would be, yeah, it would be similar.
Granted, they are different functions in terms of what they actually do.
But I think that's fair then. So if you're going to use Google Docs for collaborating on a Word-like document, GitHub would be something like that for collaborating on code. Now, when I say collaborating, though, typically in the way I'm going to use it in my class, some of you might go and use it for some of the projects you're working on and collaborate on it that way, but I use it as a convenient way for you to submit your homework to me and for me to deliver code to you. Because you're already seeing that so far we've had projects that have two source code files with like driver.java and fraction.java, right? And what have I been doing? I've been copying and pasting the two different classes and pasting them into Slack, right? Well, let's call that palatable for two classes. Not necessarily convenient, but palatable. But you start getting 3, 4, 5, 6, 10, 20, 50 classes in there, things are going to start to suck, right? All right, so with that in mind, this is where GitHub comes in, where you can have your entire repository, all those files stored up inside of GitHub, and then you can, when you go to a different machine, you can check out that repository. So we'll kind of talk about the cadence of this in the next several minutes. Go ahead.
So could you in theory run code on GitHub, or is it just like a storage?
Storage, only storage.
Do you want to have a different repository for every single project?
Probably, yeah.
So is there a way that,
Within a project, you can create branches of a single project. So if you are working on Both of you are working on the same project and you're working on like the next version and you're working on bug fixes for the current version, you can create a branch,
Okay.
which makes a duplicate of it within the same repository. And then you can be working on your branch. So maybe this is, the beta branch and this is the release branch, and those don't conflict with each other.
Okay.
And then eventually you can merge that into the release, or you can just rename the release to last version, and then the beta branch to release.
Okay.
Something like that. So yeah, it has tools for doing that. We're not going to go that deep into all the features of GitHub in there, so I'm going to introduce the tool to you in this class, and then the way you're going to use it as far as my class goes is when I have code, I will, because notice we keep basically changing the current code we have. I haven't really created a new project recently. We will create some new projects, but what I'll do is at the end of class, I will push my changes. I'll commit my changes to the local Git repository. Then I'll push those changes to GitHub. You'll have my link to my GitHub repository. So you'll be able to at any time see that. Make sense? And then I'll talk about how the cadence works here. But does everybody kind of get what Git is versus GitHub? Git is the local technology that we're using. It's like having Microsoft Word on our machine, except it's a program called Git. GitHub is a place for us to remotely store repositories so other people can view them. Because if it's on my machine, only I can view it, and if my machine crashes, I've lost it. But nothing says you ever have to put it up in something like GitHub. You can store your Git repository inside of like Dropbox, or inside of what's Microsoft's version of Dropbox called? This guy. OneDrive, yeah. So, and Google has their own version of it. So whatever, you have your folder that's on your machine that automatically syncs to the cloud. You could put your Git repositories in there, and that's sort of like your own personal GitHub, let's say. Doesn't give you a convenient way of just sending somebody a link and saying, here's my code, but it allows you to have your stuff backed up. Yeah.
Is there a way that we can use GitHub to kind of like have our portfolio? So when
In fact, it's common.
Okay.
Yeah, when you apply for jobs, sometimes they ask you for your GitHub link, so they can see all of your repositories, all the code you've uploaded and things like that. So by having you submit homework through GitHub and then give me the link, later on when you start applying for jobs and they ask for your GitHub link, you give it to them and you have 400 assignments you've turned in before, and it looks like you have a lot of code up there. At the very least, it tells a story that you have experience using GitHub, which is an industry standard tool. All right, so let's look at the cadence of how GitHub works before we actually start doing it. All right. So I'm going to just say folder of Java files for our little example here. All right, so that's what's on my computer. So for us, this is going to be like our source folder in Eclipse. So one of the things, so Eclipse is an IDE. It's a tool that manages a folder of Java files, among other things, but let's just say that's what it does. All right, the things that we create in Eclipse are going to be Java files, and those get stored in a folder. So on our local machine, we have a folder of Java files. And what we do is we create a Git repository. And that Git repository manages that folder of Java files for us. So we effectively convert a folder into a Git repository, where the Git program keeps, they create an invisible file they create a couple of invisible files in there, and I'll show you those as we go through today. But it manages the changes you've made to your code. This is all local. We haven't even touched GitHub yet. Okay, so you could actually just stop here if you wanted to. If you just wanted, I'm a individual developer, I just want to make sure that I've retained changes to my code just in case I make some horrible mistake or something like that, or I get too far down the wrong rabbit hole and decide, you know what, I need to go 7 revisions back. And we're not even going to look at rollbacks in here. You can go in tons and tons and tons of GitHub tutorials out there. It's a tough enough tool. It's not a difficult tool. You just have to learn its little cadence. This is the way you use Git and GitHub to accomplish something. So I'm going to keep it simple where the goal is for me to put stuff up, for you to get that stuff, be able to change it, submit it to me. Make sense? And then you can expand your knowledge on GitHub from there. All right, so from an individual user's perspective, we have a local folder of Java files, and we create a local Git repository. All right, now we have a GitHub account. And GitHub holds a collection of repositories for you. Now, these collection of repositories can be public or private. I was starting to say this before. Historically, GitHub was completely free for public repositories, but you had to pay for private repositories. They had a couple of different pay models where you could either have I think one private repository was maybe like $5 a month, but there was a way you could pay. I think it was maybe 15 or 20 bucks a month for unlimited repositories, something like that. They had a couple different pay models. But one thing GitHub has is if you register your account with your .edu, private repositories are free. So if you're an educational user, your private repositories are free. There might be some, I don't want to advertise incorrectly. I don't think there are, or at least I'm not knowledgeable that there are, but there may be some commercial use rules associated with GitHub with private repositories. If you are using a private repository for GitHub for commercial use to make money on some software project that you're working on, they might have some sort of rules against that. But for stuff that you're just working with your friends or whatever, not a big deal. It probably isn't even a big deal if you're using it for commercial use. But check into that in case you're going to make the next $1 million app or whatever, at which point just make sure you never cross the line where you owe them anything at that, once your app starts taking off, pay your $5 a month for your private repository and then you own it. But look into that or whatever. That's probably not something any of us have to worry about in the next 5 minutes. But for what you'll do in here is all your repositories will be public repositories. That way I can read it. Okay? If you're working on your own projects, you can make them private if you want and only have the collaborators that, the people you're working with able to see it. But unless you're doing something life-changing, just make all your repositories public. That way if you have a question, you want to ask me a question, you want to ask somebody else a question, you can just send them your GitHub link real quick and say, hey, can you look at this code? Something's broken. Make sense?
Do they need the link or can they just search it?
They could search it, but
Okay.
it would be easiest just to give them a link because they could always just refresh that link and see your latest changes. So they could just be on the web page. You could say, okay, let me make this quick change. And you push that change up there and then they can refresh the page and see, okay, I see the change. Yeah, that's still broken. So, something like that. So it's very convenient. All right. And it's not like a made up tool. It's something that you will use in industry. All right, so you have this GitHub account. This is up here in the cloud at github.com. And like I'm saying, create that account using your cuw.edu email. And then you'll be able to, you might have to hit a box that says I'm an education user too. But I think they validate you off your email. So if you use your edu email, then I think you're basically instantly validated as a education user and you have unlimited private repositories. All right, so this is what happens. So you have, let's see, I'm actually going to draw 2 lines here. So in terms of the relationship between your Java files and the Git repo, we commit changes to the local repository. So we have been working on our project for a little bit. We've made some changes to file x.java. When I've done making those changes, if I say, okay, I'm in a position now where I want to update my Git repository. Some people will just always update it. Other people might say, I'm only going to update my repository when it's in a stable state. That is, I have a program that currently runs. All right, so if you are storing your project file inside of like Dropbox or something like that, where everything's backed up anyways, that's probably what I would recommend you do. Is at any point in time, your committed repository or your repository should be representative of an application that runs. And then when you're working on your project, from that point forward, making changes, getting stuff ready for your next homework assignment, you would then, once it's running, or in some sort of stable state, at that point, you could commit those changes to the local repository. Okay? So you might have a local copy of the files, but the actual changes you've made since the last commit wouldn't necessarily be in the repository yet. So once you're ready to actually add it to the repository, you just commit those changes. That's the vocabulary. All right? Now, similarly, we can do a pull from the repository. All right. So let's say that we, well, this is actually somewhat of a lie. Here. I'm just going to call this rollback, but we're not going to actually talk about this. You do have the option to go and grab an old version of your file from your project and update your local files because you think you would be better off starting from where you used to be than where you currently are. Something like that. All right, so you can roll back to a previous file. It actually would be done through a pull, and it would say, hey, the file you currently have is out of date with the file you have stored. You have to do like a special thing to make it work. Whatever, let's just not worry about that right now. Shouldn't be a big deal if you only ever commit working stuff. All right, it shouldn't be something that you have to use very often. Okay, so this is how your local cadence will work. Generally speaking, for us, you will only be working on local files and committing those changes. That's how you're actually going to function with this. Okay? So if I'm going to really draw the correct picture here for us, you will work with Eclipse, and then once you're in a position that you want to make changes, you commit those changes to the local repository. All right? Now, once you have your local repository in a position where you want it to be updated in the cloud at GitHub, you would do a push. Push local repo to remote repo. All right, so you somehow, I'm going to show you a tool. We're going to use Git Desktop in here, which is GitHub's tool that makes it graphically pretty easy to accomplish this. So you will let your local Git repository know about your remote Git repository. That way, when you have a committed version of your repository, you can hit a button that says push, and it will throw it up here. It doesn't move it, it duplicates it. So you have now two copies of your repository. You have your local one, and you have this one that lives up in the cloud. All right, and that's done through a push. Similarly, you can do a pull. All right, so you can say that you want to pull from the cloud repository down and overwrite your local repository. This kind of goes back to what he was saying initially about collaborating. All right, so let's say that you and a friend are both working on the same project, and you're both committing and pushing to the same GitHub account. And let's say we've kind of decided amongst ourselves that I'm going to work on part A, you're going to work on part B, you're going to work on part C. And let's say this is me over here, and I've committed my changes to part A, and I've pushed those changes to the remote account. Presumably, because we were organized together, I only made changes to parts of the application that pertain to part A. So you doing a pull would then not break any of the files you've been working on, right? It'll tell you if there's conflicts, right? But when you do a pull, so when I do a push up here with my part A changes, what you should do when you first sit down, if you're in a collaboration environment, is you would say, okay, I sat down, I'm going to get ready to work on my local files, but I'm going to do a pull first to make sure I have the most recent changes to the repository, which presumably should get me all of the part A changes, which hopefully, if everybody's following the rule of only committing functioning code, might be buggy code, but it should function. Okay, it shouldn't be broken. If we always only commit functional code, then when this guy, if he's only committing functional code here, that means he's only ever pushing functional code here. And if he's only pushing functional code here, when this guy pulls the latest version of the repository, it should have any updates other people have made, but should not change his own files as long as the people have stayed organized and said, I'm only touching part A stuff, you're touching part B stuff, you're touching part C stuff. All right. If you start working on each other's files, that's not against the rules, but now you might have to, look at those changes as you do a pull. They'll say, here is your file looks like this. The file you're pulling looks like this. Here are the changes. What do you want to do? Keep the old file, take the new file, merge the two. So it could be that maybe maybe you wrote a brand new function inside of a file I'm working on, and it doesn't conflict with anything I'm working on. It's just an added function. Then I might just say, oh, go ahead and merge his change with mine. No problem. But if I have a function called do something, and they have a function called do something, and their do something does something very different than my do something, now I need to make a choice of which do something is better. Is the better do something? And keep one of them. All right. So it does become, it's a good collaboration tool, but it also does require human intervention and, human beings being organized in and of themselves. Go ahead.
When you pull something from a GitHub account, does that change anything in your local folders? Or
Well, it'll change it in your Git repository, yes. So I'm going to kind of talk about how you'll accomplish this for your projects. I'm going to show you kind of the ghetto way of doing this that should work for everybody. We'll do it in a little bit more. Android Studio, which we'll be working on the second 8 weeks, it has a built-in Git repository that's much easier to work with. Where Eclipse is a little bit wonky. Not that it's bad. Actually, the truth is I've used Android Studios a lot. I've used Eclipses a little bit, and based on my observations, Eclipse is pretty wonky, and Android Studios is pretty easy to use. That could just be user inexperience, potentially, right? But I've used plenty of Git repository stuff on different tools, so I feel like can pick out a good one versus a crappy one, but who knows? Yeah, but we're going to talk about the idea here of what will actually work in class. All right, so again, this is a collaboration thing that we aren't going to be doing in class here, but this is more for those of you who are going to be working on projects that kind of want to know how this works. Okay, so we do pulls to bring our local repository up to date with the cloud repository. Make sense? All right, so that is how you will work with this as an individual. Now, let's see, I'm going to I'm going to move this stuff a little bit just to give me some space so I can show you the whole picture here. All right, so we're going to label this. Did I click it? Did it go somewhere? I did. So we're going to label this student. Okay. Now, I'm going to have another version of this guy over here. And this will be Mr. Gonzalez. If you didn't already know, I steal all my code from him. The dude is gifted at coding, especially when you consider he basically doesn't have fingers. So
What does he type? You know, is he typing on the computer?
he uses his mind. Actually instructs the computer telepathically. It's weird. You should actually hear the noises he makes when he's doing it.
Code
Wait, so he's literally direct. He has more of a direct path to the computer than he does.
All right.
Incredible.
All right. So this is Mr. Gonzalez over here. He's going to be doing his, same kind of things that you would be doing. He's a separate user pushing things to his GitHub account, right? So now the idea would be that he's writing code in class, and at the end of class, he's leaving his GitHub account, his repository for whatever assignment we're currently working on, in a state that is your starting point for your homework. Okay, so we have a problem. Now, you could I'm just going to kind of draw the arrow towards this. You could do something called clone or check out that repository. All right, so you would be checking out Mr. Gonzalez's repository, and you can make changes to it, but you would not, and you can make changes to it and you can commit them locally, but you would not be able to push those changes back to where it came from because you don't own that repository, right? So you can go on to GitHub and you can check out or clone the latest version of the Linux source code to make changes to it and things like that. But unless they've invited you to be a contributor to the code base, you won't be able to push changes back up there, which is good because if you're working on your homework and I've given you a starting point, I don't want you to update the starting point with your changes, all right? Because when Clancy procrastinates and doesn't start his homework until 3 in the morning the day it's due, he doesn't want to start from Noah's crappy code. He wants to start from Mr. Gonzalez's good working starting point, right? So you can't change that starting point because you didn't own this global repository. Okay? Now, we're going to start operating in some geek joke area. So this is kind of some fair warning. If you look at GitHub memes or something like that, you're going to see the word fork very often. And there is, I'm going to give you the backstory because this is going to turn into a little bit of a giggle fest here, then a lot more giggle fest in like an OS class or a systems programming class and things like that. But the appropriate way to do this is if you want to get a copy of my starting point into your GitHub account and then check it out from your GitHub account so you have permission to make changes to it, what you would do is fork the repository. Okay. So far, we haven't done any giggly damage until you start hearing the ways that this is often used. All right. So fork is something. So let's talk about the history of forking. Make sure you enunciate whenever you're using this term. Enunciate every syllable. The history of forking. There is a system call. It's a function on Unix operating systems called fork. This is a function. And this function creates a clone of a running process, or we can think of this as a program. Okay, so you have a computer program. This is the early days of multitasking, where you have, or early days of a program being able to do two things at once. I'm not going to get into too much of the operating system size of things, but today we use threads. We have multi-threaded applications. Before that, we used forks, where we created a duplicate of the process, where the duplicate would decide, am I the original or am I the clone? Okay? And the original might keep doing certain logic, and the clone might go and do some other logic. So you kind of have two separate things happening from the same program. All right? So what ends up happening here is the parent forks a child process. All right. So we create child processes or clones. One time I was in this diner having breakfast with some guys that were Unix sysadmins at Western Illinois University, where I used to teach, and we were talking about this program we were working on, and so we're just having this tech conversation, right, about forking children and reaping. Reaping is when you kill off one of the children, so, we're talking about this program they wrote called Reaper, which would go out and find, lost children and kill them off. And the older ladies sitting behind us were not happy, to say the least. All right, so point is, this is based on historical computer science stuff. It just happens to be an unfortunate function name because of some of the vocabulary used in the context of it. Forking a child process might come off funny to some folks that aren't in the know. Okay? Makes sense? But so this fork system call creates a clone of a running process. So modernly, of course, GitHub, instead of calling the button something else or whatever, if you go into GitHub here, do I have more tabs now?
Yeah, that's right.
So I can go into, let's see, I'm not going to see it on this one because this, here. So here's my, we wrote a MIPS processor in one of my grad classes this semester. So I can see that one person has forked my project. Enunciate. I can even see, this allows me to say.
Worse and worse.
It even lets you pick a location. All right. So get it all out of your system. All right. So what you will do as the student, here, is you will go to, I'll give you a link to my Git repository. So for instance, if you had your GitHub account and you wanted to go and get your own version of this MIPS repository, you would go to my page. This is, github.com mlitman/MIPS repo. So you would go to this page and you would click on fork. And what that would do is it would give you a copy of my repository in your GitHub account. and you own that version, because changes you make to that will have no impact on mine. Okay, so you are cloning my project. Clone would have made a better choice there, right? Especially since they're perfectly happy using it here. So clone or download, this allows you to, because clone is one of the Git function calls. So the Git protocol allows you to say, I want to clone a repository, and it will make a copy of it and download it. But you can also just download a zip, or you can open it in Git desktop, which is what we're going to use in here. All right. So having said that, the first thing you would do when you have your starting point for your homework is you would fork the repository, giving you a local copy of it in your GitHub account. Then you could check it out using Git desktop from your GitHub account. And by doing that, you now have permission to push changes back up to your GitHub repository. So when you submit your homework, you'll give me your link to your repository in your GitHub account, so I can view your code. Make sense? So you'll start with my code by creating a copy of it in GitHub, and you do that by forking my repository. Make sense? All right. Eventually, you'll say it enough times where it won't be funny anymore, and now it just becomes funny when you're saying it around people who don't know. All right. So let me show you Git desktop. So I'm going to go ahead. Actually, I'm going to just do a search for it here real quick because I already have it on my machine. And I'll put a link to it here in Slack. All right, so there is Git desktop. So everybody should go there. You don't have to do it right now, but you go there and download this for Windows or for Mac, whatever platform you're on. Okay, and this is going to give you something. And let me. So I'm actually gonna create a copy of my current code. So let's see, what does my current code do? All right, we're not actually using fraction at this point. So here, I'm gonna get some working code going here. All right. Fine, that's just the crap we did last time, where I'm actually not using fraction inside of main, but I do still have my fraction class here, right? Okay, so what I'm gonna do is I'm gonna go ahead and put this repository up on GitHub. And the assignment I'm gonna give you for next class is for you to fork it, check it out, then, well, you actually don't even need to check it out, but I'm going to want you to check it out so you can get into Eclipse and run it. So I'll probably have you turn in a picture of it running on Eclipse, and then submit to me a link to your GitHub to show that you can do the whole process of getting a copy of my code, start using that as your starting point, making some changes. So maybe I'll have you change these strings or something like that, and then committing your changes, pushing it up to your Git repository, submitting a link to your Git repository so I can see it. All right, but first I need to get this into my Git repository. So I'm going to do this with Git desktop. So here's GitHub desktop. All right, and what I'm going to do, I'm going to do this in, I think I told you a little bit ago that I'm going to do this in kind of a ghetto way that doesn't rely on Eclipse at all. So this is a little bit, let's call it janky or something, but so I'm gonna, you probably won't have anything initially, but I'll hit this little drop down thing here. Oh, actually for the Mac, it's just up here. So I'm gonna go to repository, or do new. Okay, I'm gonna go to new, file, new repository. So I'm gonna create a new repository. All right, and I'm gonna call this guy, I don't know, call it fraction test or something like that. Actually, it's called CSC250. Actually, I'll just call it fraction test for this one. All right, so I have fraction test. Now I can put this guy wherever I want it. All right. I'm going to go ahead and I'm just going to put this in my downloads folder for no good reason. All right. So I'm going to put this in my downloads folder. So what this did is it created a, so I've done that so far. Just to give you a couple of things here. You can choose to initialize the repository with a README file. You don't have to do that for yours, but people who like put open source programs out there, usually the README file is the thing that automatically comes up and kind of gives you the documentation for it and stuff. So you don't have to click that. We also have this thing called Git Ignore. We're not going to use that for right now. Android Studio does use that automatically, but this allows you to have, you know, some program IDEs have 4 zillion files that are automatically generated that have nothing to do with code you created. So we don't want to store those 4 zillion files in the Git repository when they will be automatically regenerated anyways. So you can tell it which files to actually ignore, and there's all sorts of patterns in here. So like here's the Android ignore stuff and things like that. We're just going to leave it alone. We're not going to ignore anything. Not going to pick a license. So just name your repository and click Create Repository. Done. Okay, and I put this guy inside of my downloads folder. So I got this nice folder in here called fraction test. All right. Nothing special about that guy whatsoever, except I promise you, if I go into my terminal here and I do cd downloads fraction test, I do an ls, I see nothing. But if I do an ls-a, I see a .git thing in there. Any folder that starts with a period is by default a hidden folder. So cd.git will take me in there and I see stuff. That's my Git repository. Don't touch that. Git will manage that for you, okay? I'm just showing you that it's there. All right? So looks like an empty folder, actually isn't an empty folder. Make sense? All right. So now what I'm going to do is I'm going to go into Eclipse. I'm going to go to the folder here in the project I'm working with called Source. I'm going to right click and I'm going to say Show in System Explorer. And this guy is going to open inside of my, it's going to show me on my computer where that is. So inside of my source folder here, I have my Java files. Did I make an lol.java in here? I did. So I have 3 files. All right, so there's my lol.java. So I'm going to just highlight those, and I'm going to copy them. So I'm purposely duplicating my files just to separate Eclipse to just the Git and GitHub way. All right, so now I'm going to go into my fraction test repository folder, and I'm going to paste those files in there. At this point, those files exist twice. If I make changes over in Eclipse, they will not happen in here. All right, so this is probably not the best way of doing it, but it's the way we're going to do it just for our starting point. Okay, so now if I go back to Git Desktop, notice that this dude now notices changes. He says, hey, this is new stuff. These are 3 changed files in here, driver.java, fraction.java, lol.java. All right, so now I'm going to say, yes, I made changes to those files. My code is stable. So I'm going to go ahead and you have to give it a little note. So I'm going to call this guy initial commit. You can name it whatever you want. You can put any notes in there you want. But I'm going to give it because I have changed files, I have to commit those to master. Master is the default name of your local repository. Done. Committed it to master. So notice it doesn't think there's any changes. If I go in and I create a change and then copy the file over, and it'll notice there's a change again, but I've committed it locally. So my local Git repository is now up to date. Now, I actually want to put this up on GitHub. So I'm going to say publish this repository. Only the first time. Then it'll be pushes after that. So I'm going to click publish this repository. It's going to, the first time you do this, it'll ask you for your GitHub credentials. your username and password for GitHub, it probably already has mine stored in here, so it's probably not going to ask me, but the first time you do this, it will ask you. All right, so we're going to have fraction test. I'm going to go ahead and hit publish repository, so the name of it is fraction test. Yeah, it looks like it's not going to ask me, so it's publishing this now, so it magically just talked to GitHub. Now it does say I could open this repo. Oh, that's opening it in Finder. So I need to go to GitHub here. And I'll go back to my main thing here. And I should have a fraction test that just got created. Here it is here. Fraction test. So github.com mlitman fraction test. I'll go ahead and paste that into Slack. So that's the Git repository I just gave. That's the starting point for your homework. All right. So now what we'll do is I need to create like a secondary test account to do this, but we don't have enough time for that. So what you would do is you would fork this repository. It would ask you, where do you want to fork this? This is my business account, so I don't want to put it in there. But when you click this, it'll fork it locally into your repository. Then what you would do is I'm going to go ahead and I'm going to take my fraction test and I'm going to throw it away. All right, and then we'll even empty the garbage can. Empty trash. Oh, a lot of items in there since I last took the trash out.
Whoa, geez.
Must be from all the tabs.
Yeah.
All right. So I'll go ahead and I'm just going to remove this so as if it never existed. All right. So this is like your what your setup will be. So you've gone on to GitHub, you've clicked fork, so now you have my project cloned in your GitHub. So now we're going to go ahead and we're going to say we want a new. Can we do clone repository? Is that how we do it on here? Yeah. So we'll say clone repository. Now it's going to show you your repositories because you're logged into your GitHub. All right. And one of these here, I'm just going to, so there's fraction test. So you'll find fraction test on there. It's only going to show up in your repositories after you forked it. All right, so now I see it there. So it's asking me where do I want to clone it. So you can choose where you want to clone it, but I'll just put it in downloads again because the way we're doing this is we're keeping it separate from Eclipse. So we'll hit clone, cloning it to downloads. So now I have a new folder in downloads called fraction test with these three things. So I'm going to go ahead and I'm going to copy those files. All right, so I opened the folder, I copied those files. I'm going to go into Eclipse. I'm going to create a new project and call this, whatever, homework 7 or whatever the thing is. So this is going to be a Java project. And I'm going to call this guy clone fraction test. Name it whatever you want, but name your project and we'll just hit finish. And this is going to create an empty. This is going to create an empty source folder. Nothing in there. Right click on this. Say show in System Explorer. It's going to show me that source folder with nothing in it. Paste those files in it. Go back to Eclipse. We probably have to right click on this and hit refresh. Now notice it has those files in there. And now I can run that locally. Make sense? Now we did that completely without using any of Eclipse's built-in stuff because Eclipse manages their local directory system very closely. I am positive that there is a way you can directly import into Eclipse In fact, I've done it with their built-in thing. But this is a way that will work for every single one of you, regardless of whether you're using Eclipse or anything else. Go ahead.
Would you do the same thing by making a new package, or you have to make a new Java project?
I would always make a new. The short answer to your question is yes, you can. The real answer is make a new project each time. Yeah. We are doing this in a very ghetto way just to get you used to it. Make sense? Okay. So your homework for next class will be to go into, and I'll put this in Blackboard, is to go to my GitHub link, create a GitHub account for you, fork my GitHub link, all right? Then you will clone it using Git Desktop locally. Then you'll create a fresh project in Eclipse. Then you'll copy those .java files into the source folder of that fresh project so that you have a working version of my code. Make sense? Then you're going to run my code. I might tell you to make a couple of changes, like change hello to your first name or something like that. Then run it, take a screenshot so I see that you were able to successfully get it and run it. Then I'm going to have you, after you make those changes, copy the files back over to your repository, and then commit the changes local, push those changes to GitHub, submit your GitHub link that has your changes. That makes sense? That's the full cycle of what you're going to need to be able to do moving forward for your homework and stuff like that. And this is using GitHub in a not so good way. I promise you we're going to have more automated ways of using this. So this is as bad as it will get. All right? Questions, comments, concerns, bribes? All right. I'll see everybody on Tuesday.
That link doesn't work.
I probably made it a private
Yeah,
project.
because I searched it too and
Yeah.
I couldn't find it. So.
Here, let me just change it real quick, and then you can make sure it's private.
For some reason, it's like trying to authenticate my account. It's like not working.
GitHub?
Yeah.
I had problems with it when I first made mine too.
Like I can sign into it, and like when I try to clone a little repository, that's when it like says, oh, we need you to authenticate your GitHub.com account. And so I enter my username and password, and it's like says the same thing over and over again. So I have no idea. It's just kind of being weird. But when I create a repository from the app, it works. So I'm not sure. So with that.
I have a friend that works for GitHub.
All right. Refresh it now. Did it work now?
Yes.